Welcome back. We are still in chapter 1.3, working on linear equations and two variables. We have a couple of key terms to go over, and then we can start on our first learning target. So parallel lines are two non-vertical lines that have the same slope. So two non-vertical lines that have the same slope. And it would look like this. Remember, m is the way we express slope, so the first slope of the first line is equal to the slope of that second line there. And then lines are perpendicular if their slopes are negative reciprocals of each other. So this would be two non-vertical lines that have slopes that are negative reciprocals. And then that looks like the first slope equals the second slope flipped and negative. Okay? Symbols that you should know, parallel lines, the symbol for parallel lines is just like two lines next to each other like that. And then perpendicular lines is, the symbol looks like an upside down T, like that. All right, first learning target. I can determine whether the lines are parallel, perpendicular, or neither. So the way to do this is to look at the slope and see if it falls under this one or this one. Okay, so there's your success criteria. Easy enough. If m equals m, then lines are parallel. If m, first one, equals negative reciprocal, then perpendicular. So let's look at number 12. So I'm looking at my slopes, my m's. Those are my slopes, 3/4 and negative 4/3. So 3/4, it was flipped, and then it became negative. So that would be a negative reciprocal. That would be perpendicular. So these lines are perpendicular, or you can use that symbol. All right, you try 13 on your own. And 14, on to 14. Okay, so here's my learning target here. I can find the equation of a line parallel and perpendicular through a given point to a given line. Okay. So I'm given an equation right here. So I want to figure out, if I graph this line, what would be the equation of the line that goes through this point, and that first of all is parallel, and then I'm going to do another problem to find the perpendicular. Okay, so let's start with my first step, which is to get y by itself. So I'm going to write my success criteria up here. So get y by itself. So it's in that y equals mx plus b, and then we'll be able to see what the slope is. So here's my line, my given line, and I need to figure out what is the slope of this line. So I'm going to subtract the 5x and then divide by -2. And now I have my slope-intercept form there. All right. Okay, now I know what the slope of the line is. The slope of this line is 5/2. So to find my parallel line, I'm going to use the same slope because I know parallel lines have the same slope. So I know that the line parallel to this line is going to also have the slope of 5/2. So we're going to determine both the parallel and the perpendicular slope. So the slope of my parallel is going to be the same, and the slope of my perpendicular is going to be the negative reciprocal. So it's positive now, so it becomes negative, and then I'm going to flip 5/2, I'm going to flip it, so now it is 2/5, and that would be the slope of the perpendicular line. Now I can take all that information and plug it into my slope form. Into my point slope form. So that's the y minus y1 equals m times x minus x1. And I get my x1, y1 from this given point because I know that this is a point that's going to be on the parallel line. So this is x1, y1. So I'm going to plug it all in now. So y minus 2 equals 5/2 times x minus -1, which I'm going to just simplify. That's going to be +1. Now I'm going to get y by itself so that it is in my slope-intercept form, okay? So that's step 4. We're going to simplify to the y equals mx plus b form, okay? So to do this, you could distribute and then you add the 2 to the other side, but when you distribute, you're going to get fractions here. And this is what I started to do in that other problem. But yeah, so if you distribute, I'm going to end up with a 5/2, and then when I add that 2, I'm going to have to get a common denominator in order to add them together. So to avoid having to get a common denominator, what you can do is clear the fractions. So you clear the fractions by multiplying by the denominator. The denominator here is 2. So to clear this fraction, I would multiply all this by 2, but then I would also have to multiply the other side by 2 because whatever you do to one side, you have to do to the other. So these 2's cancel, and then I have to distribute the 5. So that would be 5x plus 5. And then over here, I have to multiply by the 2, so I'll distribute the 2. And so now the fractions are gone, and it's a little bit easier just to get y by itself. So I'll add 4 to both sides. And then divide by 2. So my answer is y equals 5/2x plus 9/2. And this is my parallel line. Okay, now we need to go through that whole process again to find the perpendicular. So we'll plug it in. minus a negative would be plus. And I'll clear my fractions. This time my denominator is 5. Then I'll distribute this -2. Distribute this 5. And then I need to get y by itself, so I'll add the 10. And divide by 5. So y equals -2/5 x plus 8/5. And that would be my parallel line, or my perpendicular line. Perpendicular line. Then I'll just do a quick check. I knew that I started with a slope of 5/2. The parallel line does have the same slope, and the perpendicular line does have that negative reciprocal. All right, you try 15 on your own and then check it with the key. Then let's move on to some applications. So we can work through these together. So number 16, a kitchen appliance manufacturing company determines that the total cost, C, in dollars. So C is my total cost of producing X units of a blender is given by the equation, and then they give you the equation there. So what this tells me is that to find my total cost, it's going to cost me $3,500 no matter what. That's my fixed cost. It's called a fixed cost. So this is a cost that has to be paid whether you make 0 units or you make, and we're talking about blenders, 0 blenders or 1,000,000 blenders. It's still, you're going to have to pay this $3,500. And then after that, each blender in addition is going to cost $25 each. So 25 times however many blenders you're making here. And this is called the marginal cost. Okay. So this would be the cost of producing each unit. Cost of producing each unit. Okay. So what does this all mean? Interpret the y-intercept and the slope. So if I'm looking at the form mx plus b, the 25 is the slope and the 3,500 is the y-intercept. So what do I know? So the slope tells me, this is my answer. The slope tells me, I'm not going to write this all out, but the slope tells me that it's going to cost $25 to produce each unit. The slope tells that it's costing $25 to produce each unit. And then the y-intercept tells us that the cost of producing 0 units is $3,500. So slope tells us it costs $25 per blender, and the y-intercept tells us that the cost to produce no blenders, no matter how many blenders you make, or if you make no blenders, it's going to cost $3,500. So that's what I can conclude out of that equation. So let's look at 19. It says the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that is 22 inches over 24 feet. So right there I notice I have inches and feet, so I'm gonna have to do some converting. So is this ramp that this company is making, does it comply to this 1/12 slope? Let's test it out. So slope is rise over run. So rise is 22 inches, And then the run, the horizontal, would be 24 feet, or 24 times 12, because there's 12 inches in a foot, and that would be 288. So it's 22 over 288. Then I'll just punch that in my calculator really quick, and I find out that this is 0.076. So I want to compare that to 1/12. Put that in my calculator. 1 divided by 12 is 0.083. So the slope of this ramp that the company is making is less than the required slope, so it is not steeper than recommended. So was the ramp steeper than recommended? No. Okay. Moving on to the last problem here. All right, the sales for Best Buy were approximately $49.7 billion in 2009 and $50.3 billion in 2010. Using this information, write a linear equation that gives the sales in terms of the year, and then predict what it will be like in 2013. So if I'm looking at this, I have the time in years for my X, and for my Y would be the sales. So that would be, let's just call this, let 2009 be year 9 and 2010 be 10. So my ordered pairs would be 9 and 49.7. Remember, it's a billion. Don't forget about that at the end. And then 10 and 50.3. Okay. And then I can find the slope there, because I'm trying to write an equation. So to write an equation, I need a slope, right? So I need to find that first. So I'll plug this in. Y goes on top, and then X on bottom. Solve that out. So I get my slope is 0.6. Okay, and then I can use my point slope formula to write the equation. So I can use either this point or this point, doesn't matter. I'll just pick this one. And then my slope, so this is my x1, y1 here. So y minus y equals m times x minus x. Then you have to distribute that 0.6. Okay, and then add the 49.7 to the other side, and then you have your equation. Now let's predict the sales in 2013. So remember, time is X, so I'm going to plug in 13 for X here, and that will give me my Y, my sales. And put that in the calculator, and you get 52.1, and remember that is million. So that's their sales in 2013. All right, that's the end of 1.3.